This video discusses the procedure for the classifying chemical reactions experiment for general chemistry at Madison College. For this lab, you're going to be doing 8 different reactions, and the reactions are labeled 1 through 8. Something I want you to keep in mind as you watch this video is that for the post-lab questions, you're going to be asked to predict the products and write balanced chemical equations for many of these reactions. So keep that in mind as you watch the video and as you complete the reactions in lab. The first reaction that you're doing is an example of hydrocarbon combustion. The hydrocarbon that you'll be using is ethanol. And the ethanol is a clear, colorless solution, and you'll see a bottle in the lab. Reaction number 1 is the only reaction that you won't set up independently with your partner in lab. Your instructor is going to demonstrate this reaction in the front of the room. And what they're going to do is pour the ethanol into the ceramic dish and light it on fire. And you'll see that you'll get a really big flame like this. The other ceramic dish that we have here is filled with ice, and the purpose of the ice is to help you observe the products of this reaction. The products of hydrocarbon combustion are always exactly the same. It's always carbon dioxide and water. You won't be able to observe the carbon dioxide, but you will be able to observe the water, and that's the purpose of this ice. The ice is going to make the ceramic dish cold and provide a cold surface for the water that forms in the combustion reaction. That water will condense on the ceramic dish. What you're going to be looking for in this lab is you'll start to see water droplets forming at the bottom of the ceramic dish that's close to your flame, that's close to that burning ethanol. That's your apparent product, and that's what you're going to be looking for in reaction number 1. So you're not going to set up this reaction yourself, but you'll have an opportunity to observe it when you're in lab this week. Reaction number 2 is also a combustion reaction, but this is an example of metal combustion. The metal that you're going to be burning in reaction number 2 is magnesium. For this, you want to get the longer strip of magnesium, the one that's labeled 3 to 4 centimeters. And I have my magnesium strip here. You want to hold the magnesium with tweezers or with metal tongs, and to initiate the reaction with oxygen gas, you're going to stick it in your Bunsen burner flame. This is a really memorable reaction. It's one of my favorites. Once that magnesium starts burning, you're going to see a really bright light. And it's important that you don't look at the light directly. Now, your products of the metal combustion reaction, sometimes we describe it as a combination reaction because you're combining the magnesium with the oxygen gas that's present in air. Your product is magnesium oxide. You want to observe that product, so you want to get a ceramic dish ready so that you can put that magnesium in the metal dish after it's reacted and after you see that bright light. You'll have an opportunity to observe your magnesium oxide product. So that's reaction number 2. That's a metal combustion reaction. Reaction number 3 also involves magnesium, but now you're going to be doing a single displacement reaction. And I recognize a single displacement reaction as a reaction between an element and a compound. So magnesium is the element that you're using in this case, and you want to use the smaller strip of magnesium for this experiment. So you want to use the one that's labeled 2 to 3 centimeters long. You're going to be reacting that with hydrochloric acid, so you'll see the bottles of hydrochloric acid in the lab. Remember that that's a corrosive solution, so you don't want to get it on your skin. You need about 2 milliliters of the hydrochloric acid, and you want to put that into a small test tube. You don't have to measure out the 2 milliliters precisely. You can approximate it, and I usually approximate it with 2 big squeezes from the dropper that's on the top of the bottle. You could also approximate it by counting out 40 drops of the hydrochloric acid. You're going to put the magnesium strip into the hydrochloric acid to start the reaction. What you might observe in this reaction is that the solution starts to get foggy because that magnesium is bubbling vigorously. When you see those bubbles, that's a sign that a gas is one of your products of the reaction. You're going to test that gas. You're going to test it with a splint test, just like you've done several times before. You want to find out if that gas is flammable or not. So you'll need to get a wooden splint and a box of matches, and you want to insert that flame that's on the end of your splint into the test tube to see if it goes out or if it stays lit. So you'll do a splint test to test the gas that forms in reaction number 3. And reaction number 3 is an example of a single displacement reaction. Your next reaction, reaction number 4, is a decomposition reaction. And I usually recognize a decomposition reaction as one that only has one reactant. So here you just have one reactant, and that reactant is ammonium carbonate. The ammonium carbonate is a solid, and you'll find it in a brown glass bottle in the lab. You don't need to weigh it out precisely. You just need a small scoop about the size of a jelly bean, and they'll be labeled scoopers in lab that you can use with the ammonium carbonate. You want to put a small scoop of the ammonium carbonate into a test tube, and to initiate the decomposition reaction, you're going to heat that ammonium carbonate in your Bunsen burner flame, like you can see in the picture on the right. This reaction also produces a gas as one of its products, and there's several observations that you want to make of the products of this reaction. So you want to detect the odor. Be careful when you go detect the odor. You don't want to sniff the test tube directly, but waft those vapors towards your nose. So you want to detect the odor of the product. You also want to detect that gaseous product by and figure out if it's acidic, basic, or neutral by a wet litmus test. So you're going to have to get that vial of your purple litmus paper. You want to wet a piece of litmus paper with deionized water and position it on a metal spatula. Insert it into the tube to test to see if the gas that forms is acidic, basic, or neutral. If the litmus paper turns pink, then you would say it's an acidic gas. If it turns blue, you would say it's a basic gas. You're also going to do a splint test for reaction number 4 and test whether the gas that forms is flammable or not. I should mention that you're going to be doing this reaction. You're going to hold the ammonium carbonate in your Bunsen burner flame for about 30 to 60 seconds. That will be long enough to initiate your reaction. So this is reaction number 4. This is a decomposition reaction. Your next reaction, reaction number 5, is a double displacement reaction. This is a special type of double displacement reaction because it's one that forms a gas. Your two reactants here are calcium carbonate, which is a solid. You don't need to weigh out the calcium carbonate precisely, but you just need a small scoop of it, about the size of a jelly bean again. There'll be a scooper in the lab together with the calcium carbonate, and you'll start by putting a small scoop of the calcium carbonate in your test tube. To that, you're going to add about 1 milliliter of the hydrochloric acid, or that's just one big squeeze with a dropper on the top. If this reaction produces a gas, like I said, you can expect that you'll start to see bubbling in the solution. And I've got my reactants mixed in the picture on the right, but it can be hard to see those bubbles here in the picture. So you'll have to observe the reaction that you do in lab to see that. You want to test the gas that forms in this reaction, and you're going to test it doing a splint test again. So this will be another splint test that you do for reaction number 5. You want to find out if that gas is flammable or not. So reaction number 5 is a double displacement reaction that forms a gas. Reaction number 6 is another example of a single displacement reaction. In this case, the compound that you'll be using is copper 2 chloride, and copper 2 chloride is a clear blue solution. You're going to be reacting that with zinc metal. And the zinc metal that you use for this lab kind of looks interesting. On the bottle it says mossy zinc. And it's mossy because it's really porous. It has a high surface area. And this helps in its reaction with copper 2 chloride. You want to get about 2 milliliters of the copper 2 chloride, so that would be 2 big squeezes with the dropper on the top of the bottle. And you want to put that in a test tube. To that, you want to add about 1 to 2 pieces of your mossy zinc. You want to let this react for about 10 to 15 minutes before you record your final observations of the reaction. You might want to observe the metal at the end of the reaction. You might want to observe the changes to your metal outside of the solution. To do that, you might want to filter the metal out over a paper towel so that you can observe the metal alone at the end of the reaction. We also want you to do this because we don't want that metal going down the sink in the lab. So for reaction number 6, it's going to be important that you dispose of that in the metal waste container in the front of the room. We don't want any of the zinc going down the drain in the lab because it would clog the drain. So dispose of that in the metal waste container in the front of the room. All the other reactions that you do, you can wash the solutions down the drain, and you can wash your test tubes in the sink like you normally do. So reaction number 6 is the only one that has a special disposal container. Reaction number 7 is an example of a double displacement reaction. Here you're going to be using copper 2 chloride again. And again, you want to get about 2 milliliters of copper 2 chloride in a small test tube. To that, you're going to add 25 drops of sodium phosphate. And the sodium phosphate is a clear, colorless solution that you'll find in the lab. This double displacement reaction is sometimes called a precipitation reaction. It forms a solid as one of its products. You might see after you add that sodium phosphate that the solution starts to get cloudy, and that's your clue that a solid is forming in your reaction. You want to write down your observations of your solid in your data table for reaction number 7. So this is reaction number 7. This is an example of a double displacement reaction. Your last reaction, reaction number 8, is also a double displacement reaction, but it's a special type. We could also call this an acid-base neutralization reaction. You're going to be reacting sodium hydroxide, that's your base, and you're going to react that with hydrochloric acid, which of course is your acid. You want to start off with the sodium hydroxide, and here you want to be more precise. You need to weigh out you need to count 20 drops of the sodium hydroxide. I would suggest that you use the disposable droppers that are in the back of the lab room. They have a narrow tip so that it makes your drops more uniform when you're counting drops. So I would get 2 of those disposable pipettes and use one for the sodium hydroxide to count out 20 drops, and also one for the hydrochloric acid. You'll start with your 20 drops of sodium hydroxide, and to that you're going to add 1 drop of the phenolphthalein solution. Phenolphthalein is your indicator. When you add 1 drop of the phenolphthalein, it's going to turn the solution a dark pink color, like you can see in the picture on the left. You want to neutralize that sodium hydroxide. To neutralize the sodium hydroxide, you're going to add hydrochloric acid 1 drop at a time. I suggest that you work together with your partner when you do this neutralization reaction. One partner can hold the test tube while the other partner adds drops of hydrochloric acid. It's important that you swirl the test tube after each drop of hydrochloric acid that you add. You're going to count the drops of hydrochloric acid that you add, and you're going to keep adding drops until the solution turns clear. At that point, you know that you've neutralized the solution. That change in color for phenolphthalein is pink when it's a basic solution, and it's clear when it's a acidic or neutral solution. So that's going to be the sign that you've neutralized the base of your reaction. You're also going to do a litmus test to confirm your results for this reaction, both before you add the add the hydrochloric acid and after. This is the end of the procedure, and I hope this video helps you prepare for lab.